Now let's talk about one of nature's more impressive demonstrations for a pilot, and we're talking about microbursts. Now, microbursts are small-scale, very intense downdrafts, and when they reach the ground, they spread out in all directions, kind of like pouring a bucket full of water on the floor. It all spreads out like so. Now, we in the aviation community only came to understand microbursts in the early 1970s, and in fact, we're learning more about them all the time. But they have played a very important part in a few airline accidents. Now, the reason microbursts are hazardous is that they cause both vertical and horizontal wind shear. And as you remember, wind shear is an abrupt change in the strength or direction of the wind. Now, what happens is this affects all kinds of aircraft, but especially airliners because they can't respond to wind shear as quickly as small airplanes. But it also affects all airplanes at low altitudes, and that's where you are, folks, during takeoff and landing. Now, a microburst starts with precipitation, which tends to drag the air down with it. Then as the precipitation goes to lower, warmer levels, it begins to evaporate. Now, let me ask you a question. If you have sweat on your forehead and that sweat evaporates, does that heat things up or cool things down? Well, it cools things down. So when this precipitation evaporates, it cools the air. Now, cold air is heavier, so the air starts sinking even faster, and the result is one tremendous downdraft. Now, sometimes this precipitation completely evaporates before it gets to the ground, and all you have left is that tremendous downdraft. In fact, the downdrafts in a microburst can be as much as 6,000 feet per minute. Now, let's take a look at the life cycle of a typical microburst, and it starts with convective activity. Then you have a downdraft, and that downdraft will typically be less than 1 mile in diameter until it gets near the ground, say within 1,000 to 3,000 feet of the ground, and then it begins to spread out and change to horizontal winds. Now, this microburst continues to grow in intensity, and as it does so, it spreads out even more, and finally you have about 2.5 miles diameter normally here. Now, the horizontal winds can be as strong as 45 knots in each direction. And what that means is if you're flying through a microburst, you might have a wind shear from headwind to tailwind as much as 90 knots total. And all of this tremendous amount of activity down here occurs within a few hundred feet of the ground. Now, these horizontal winds continue to increase during the first 5 minutes of the microburst. But fortunately, the maximum intensity winds only last about 2 to 4 minutes, so these things don't hang around very long. Now, as a pilot, where should you expect to find microbursts? Well, just about anywhere there's convective activity. You might find it in heavy rain embedded with a thunderstorm, or in light rain, or sometimes even in harmless appearing virga, which, as you remember, is rain that doesn't even reach the ground. Now, when there is little or no precipitation along with a microburst, the only visual clue you might have of a microburst is a ring of blowing dust, just like this. Now, as you can see, microburst-generated wind shear can create a severe hazard for any aircraft within about 1,000 feet of the ground, particularly during approach, landing, and takeoff. Now, since microbursts are most hazardous when you're near the ground, like when you're approaching to land like this, let's take a look at how a microburst might affect your airplane as you go through it on approach to land in an airport. So the first thing you'll notice when you get near the microburst is that you'll have a headwind and an increase in airspeed. And you might also get an updraft, so your airplane might tend to climb. Now, if you're approaching to land at this point, your first inclination when this happens to you is to pitch back down again and reduce power. Now, about the time you've pitched down and reduced power and slowed the airplane down, wham! You're into that downdraft. So your airplane now starts descending big time. Next, you fly into the tailwind here, and your indicated airspeed drops off even more. Now, if you're flying a big airliner instead of a Skyhawk, well, the big airliner might not respond as quickly. In fact, it wouldn't. And so in the airliner, you might run out of airspeed, altitude, and ideas all at the same time. But in a smaller airplane like a Skyhawk, your chances are much better. But How do you deal with this scenario in your Skyhawk? Well, two ways. First of all, recognize the conditions, the convective activity that might lead to a microburst. And second, when you see any sign of a microburst or you feel that first sign of an updraft, go around, get out of there. Now, it's almost impossible to predict exactly where microbursts will occur because they're small and they have a short lifespan. But your first clue as to the possibility of a microburst is a forecast of convective activity. And some microbursts don't even have precipitation that reaches the ground, so they wouldn't show up on radar. So sometimes the very best way to find out about microbursts is from pilot reports from your fellow pilots like this guy right here. But be careful. As you remember, wind shear intensifies very rapidly in its early stages, so even a pilot report may not give you the latest information about what's going on regarding a microburst. Now, airports that are very big and have the equipment can also help you out by giving you microburst alerts and wind shear alerts. And if you get those, you know that there's something going on in that area regarding microburst. Now, once microburst activity starts, you can expect that other microbursts will occur in the same area, which means that if you do hear a microburst alert near an airport, you might not want to take off or land there. Now, here's the good news. It is very rare indeed for an individual microburst to last longer than 15 minutes from the time that it whacks the ground until it completely dissipates. So if there is a microburst at the airport you intend to use, chances are pretty good it'll be gone in about 15 minutes. On the other hand, sometimes microbursts do converge into a line structure, and they could last as long as an hour. But all in all, microbursts are one of nature's very impressive demonstrations. And frankly, I and most other pilots prefer to witness this kind of demonstration from a distance.